Hello everyone. In this video we are going to discuss relative velocity. We all know what velocity is. It is displacement upon time, or we can say distance traveled by a body per unit time in a particular direction. But when we talk about relative velocity, it means the velocity of measuring the velocity of a body with respect to another body which is also moving. So that is known as relative velocity. Suppose we are moving in a car, and if another car, suppose your velocity of your car is say 40 km per hour, and another car passes from your side, coming from your back in the same direction and with a velocity of say 60 km per hour. Sitting in your car, it will appear that the velocity of the other car is only 20 km per hour. But the same car, if it comes in from the opposite direction and crosses you, you will find that the speed now becomes 100 km per hour. So the same car moving in the same direction with 60 km per hour appears to be 20 km per hour, and same car moving with 60 km per hour from the opposite direction appears to be 100 km per hour. That is called relative velocity. We are measuring the velocity of a moving body with respect to another moving body. Okay, so that you need to understand. We are going to discuss that only. So when we consider relative velocity, it is the velocity of an object with respect to another moving object, and is the effective velocity with which the object will appear to move when the other object is considered to be at rest. That is, two of the object is moving. You are sitting in one of the object and you are measuring the velocity of the other objects. The object in which you are sitting is considered to be at rest. Like you are sitting in a car, you feel that you are at rest and you are watching the other car which is moving, and you measure the velocity of that other car, considering yourself at rest. So that is called the relative velocity. So that's what we are going to discuss here today in this video. The first option that we are taking is when the objects are moving along a straight line. The first condition here is when the object is moving in the same direction. That is, two bodies are moving in the same direction. Let us consider with some diagrams here. Two bodies A and B we are considering. Suppose they are the two vehicles we are considering, A and B. A is moving with the velocity VA as shown here, VA vector, and B is moving with velocity VB. Now you are sitting in B and you want to measure the velocity of A, but you yourself is moving. So what you do is you have to consider yourself at rest, and then you will measure the velocity here, measure the velocity of A, and that will be called the relative velocity of A with respect to B. So to do that, what we are measuring it from B. So B has to be at rest. So we are subtracting minus VB. So what we can say in terms of vector addition, we are adding vector minus VB to VB so that it becomes the relative speed here or velocity here becomes 0. So the same thing we add here, minus VB we are adding here. So what we finally get is B comes to rest, VB minus VB is 0, and the term here VA plus, this is in the opposite direction, so you can see the magnitude or the length of VA is reduced here, and it is VA plus minus VB. So when we write the relative velocity of A with respect to B, so this value has to be written, which is VA, vector VA minus vector BB. So VAB is, that is the relative velocity of A with respect to B is VA, vector VA minus vector VB. Now let us understand it more clearly. We got the relation here, like you are sitting in B and you are measuring the velocity of A. You also are in motion here with a velocity vv, and the body which is in motion with velocity va. But va and vv, they are not the relative velocity. The relative velocity is represented as vab. That is, you are sitting in b and you are measuring the velocity of a, which is vector va minus vector vb. Now, you see here, if the value of va is 60 km per hour, vb is 40 km per hour, they are in the same direction, so their signs will be positive. So if we take va as 60 km per hour and vb as 40, so it is 60 minus 40, that is 10. So actually what happens is the magnitude of the resultant velocity of a with respect to b will be the subtraction of the greater value minus the smaller one, va minus vb. So that is written here. When the two objects a and b move in the same direction along a straight line, the magnitude of the relative velocity of the object a with respect to b is equal to the magnitude of the velocity of object a minus the magnitude of the velocity of object b. That is, two vehicles moving in the same direction. You are sitting in one vehicle and the other vehicle passes you. Its actual velocity, whatever its actual velocity, it appears to be lesser. So that is relative velocity. Now we are considering the next option, when the two vehicles or two bodies are moving in the same path, same line, but in opposite direction. VA in this direction and VB in the opposite direction. Now, again in the same way, we need to consider B to be at rest. We are sitting in B, so B has to be at rest. So my minus VB is in this direction. So VA and minus VB are in the same direction. So what happens is, you will find that the magnitude of VA is added upon by minus VB, and the length here increases and B comes at rest. So again the relative velocity of A with respect to B will be given by this same formula that we will write here. VAB, vector VAB is equal to vector VA minus vector VB. But when we find the magnitude of the resultant velocity, to find the magnitude, if this is 60 km per hour and this is 40 km per hour, their directions are opposite. VA is positive and VB is negative. So if we put 60 km per hour minus 40, that becomes plus. That means two quantities are added up. When the vehicles are moving in the opposite direction, for an example, so their relative velocity appears to increase from their actual velocity. As you see that when you are moving in a vehicle, in a car you are sitting and another car crosses you, whatever velocity it crosses you, whatever may be its actual velocity, it appears to be more than that velocity. So that is called the relative velocity. I hope this is clear to you. The same thing is written here. When the two objects A and B move in opposite direction, magnitude of the relative velocity of object A with respect to the object B is equal to the sum of the magnitude of their velocities. So a very simple thing you need to understand, when the two vehicles are moving in the same direction, you have to find the relative velocity of the one with respect to another. It decreases. And when they are crossing, that is in the opposite direction, if they are moving in the opposite direction, then the relative velocity will increase. The magnitudes are added up. Now next condition what we are going to see here is when the motion of the two objects is inclined to each other. That is, now we have already considered the conditions in which we have seen that they are moving in the same line, either in the same direction or in the opposite direction. But now this time they are not moving in the same line. They are moving in different directions. Take the example which we have shown here. VA in this direction, VB in this direction, and they make an angle of theta, which is shown here. Now we are going to find the relative velocity of A with respect to B. So B has to be at rest. So we added minus VB in this direction, in the opposite direction. So B comes to rest. So in the same way, since we have added minus VB in this direction, same direction we add minus VB here also to VA. So we will use the parallelogram law of vector addition, because minus VB and minus VA, they form the two adjacent sides of the parallelogram starting from the co-initial point. So this will be the resultant vector VA. In the same line, if they were moving in the same direction or opposite direction, the resultant was calculated either by adding or by subtracting. But here the resultant will be calculated by the parallelogram law of vector addition, and we will see that VAB, the magnitude of VAB, the resultant of vector velocity of A with respect to B, will be given by root over, if you remember the formula, root over A square plus B square plus 2AB cos theta. So here it is root over VA square, the magnitude we are taking, plus plus magnitude of minus VB. This minus sign doesn't have any meaning because we are taking the magnitude square, plus 2AB cos theta. So this is VA, this is minus VB magnitude, and cos theta. Theta is the angle between VA and minus VB, which is 180 minus theta, because this angle is theta, which we have already considered here. So this is 180 minus theta. So here we write cos 180 minus theta, and cos 180 minus theta is minus cos theta. We have taken the magnitudes here, VA vector with modulus, it is written as VA only, minus VB, it's VB only, VA and minus VB, VA and VB, but cos 180 minus theta is minus cos theta. So that's why a negative sign has come here. So I hope this is very clear to you. The relative velocity of A with respect to B, in case when the A and B objects are moving in different inclination, not in the same path, then the resultant is given by this formula. Now, suppose we consider that we need to find the direction of the resultant now. Now, this angle which the resultant makes with VA, let it be given by beta. So if this angle is beta, so tangent beta, we know the formula for tangent beta is equal to opposite side, that is this opposite side here will be minus VA only. So we have minus VB only. So we have tangent beta will be equal to the magnitude of minus VB, which is written here, sine of the angle between them, which is 180 minus theta. This angle between VA and VB, which is VA and minus VB is 180 minus theta. So that value we are writing here, and divided by VA plus minus VB cos 180 minus theta. So sine 180 minus theta. This is the formula which, if I remind you, if you consider tangent beta is equal to B sine theta by A plus B cos theta. So that kind of formula is the same formula we are using here. Here it is B, instead of B it is minus BB modulus. Sine theta is 180 minus theta. A plus B cos 180 minus theta. Again the same values, modulus, the negative sign doesn't have any value, so it is B here, here it is VA, and minus VB is also VB, but cos 180 minus theta is minus cos theta. So that's why the negative sign is coming here, and sine 180 minus theta is sine theta only without any negative sign. So this is the value which, through which we get the direction of the resultant magnetic direction of the resultant velocity. So the relative velocity of A with respect to B, in case of A and B are moving in different directions, is given by the formula here. The magnitude is given by root over VA square plus VB square minus 2 VA VB cos theta, and the direction will be given by beta, which is tangent inverse VB sin theta divided by VA minus VB cos theta. So I hope that this is very clear to you. Any doubt, you can post me the doubt without any kind of hesitation, and it will be taken care of. So thank you.